Good morning, viewers. Welcome to my channel, Sir Ken Maths Hub, the solution to your math problems. We're still on bearings. We are looking at distance bearing problems. Question 6, I read. A cyclist starts a journey from town A. He rides 10 kilometers north, then 5 kilometers east, and finally 10 kilometers on a bearing of 45 degrees. So let's represent the first information on a diagram. So he started the journey from town A. So this is town A. So from town A, he rides 10 kilometers north. 10 kilometers. So there is the north direction. So from town A, the north direction, distance covered was 10 kilometers. So this is his current location. Then 5 kilometers east. So from here, he rode 5 kilometers. So there's a direction for east. A distance of 5 kilometers, so 5 kilometers east, and finally 10 kilometers on a bearing of 45 degrees. So from here, you rode 10 kilometers on a bearing of, so this is our geographical note. You said that for the three figure bearing, angles are read from the geographical note in the clockwise direction. So from the geographical note in the clockwise direction, we have to measure 45 degrees. We have to measure. So here is 45 degrees in this direction at a distance of 10 kilometers. So as you can see, from town A, you rode 10 kilometers north, and then 5 kilometers east, and then 10 kilometers on a bearing of 45 degrees. So that is what we have done. A, how far east is the cyclist's destination? So this is his destination. So how far east is the cyclist's destination from town A? So how far east? So this is how far east they have traveled. So this distance here from A to this point, this distance here represents how far east they have traveled. How far east they have traveled from A to this point. That is how far east they have traveled. B, how far north is a cyclist's destination from town A? So how far north? So this is how far north. So this is his starting point, and this is his destination. So this line here represents how far north he is from the starting point. So from A to this point, this distance here represents how far north he has traveled. But again, we see that the distance from A to this point is also the same as the distance from this point to this point. So I'm going by this side. The distance from A to this point is also the same as the distance from here to here. So this line here also represents how far north he has traveled. So I'm cleaning this side. I'll be focusing on this side here. So now, okay, let's make it a straight line. If the distance from this point to this point measures 5 kilometers, then this point to this point must also measure 5 kilometers. So let's take note. And so that is for how far east he has traveled. So how far east he has traveled has been divided into two. one part measuring 5 kilometers. So all that we need is to calculate this length. So when you add the two lengths, that will give us how far east you have traveled. And if from here to here measures 10 kilometers, then from this point to this point you must also measure 10 kilometers. So meaning that for how far north you have traveled, it has also been divided into two. One part measuring 10 kilometers. So all that we need is to calculate this height here and add it to the 10 kilometers, and that will give us how far north you have traveled. But let's focus on this particular shape here. See that this is a right angle triangle. So we have our right angle triangle here. So meaning that from this right angle triangle here, we have to calculate this length, so that when we add this length to the 5 kilometers, that will give us how far east you have traveled. We are also to measure this height, so that when we add this height to the 10 kilometers, to give us how far north you have traveled. So before we even start the calculation, let's label our diagram. So here is A, I'm labeling here as B, this point here as C, this point here as D, here as E, here as F, and then here as G. So that is what I've done. So now, how do we name this right angle triangle here? So I'm naming this right angle triangle CDE. CDE. So now, from this right angle triangle, before we can calculate this height and then this length, we will need at least one acute angle inside the right angle triangle. So now, there is a quadrant. As you can see, there is a quadrant. So we have a quadrant here. We have a quadrant here. And what is the measure of a quadrant? That is 90 degrees. And this quadrant has been divided into two. One part measuring 45 degrees. So what will be the measure of this angle here? So here we also measure 45 degrees. So can we identify the sides of our right angle triangle? So since this is acute angle, this side here becomes our opposite, because it is the side facing the acute angle. This side here becomes the hypotenuse, because it is the longest side. Again, it is the side facing a 90 degrees angle. And then this remaining side here becomes our adjacent. So the A part says that, so for the A part, from this right angle triangle, from triangle CDE, we are looking for the A part says that we have to calculate how far east. So let's calculate this length. So to calculate this length, we will need adjacent and hypotenuse. So from SOHCAHTOA, which of them has adjacent hypotenuse? So that is K. So what does K say? K says that the cos of the acute angle here, 45, must be equal to the length of the adjacent. So I'm naming the adjacent as line CE, divided by the length of the hypotenuse, which measures 10 kilometers. So cos 45 is the same as cos 45 on 1. We can cross multiply. 10 times cos 45. So 10 cos 45. And then 1 times C, that should give us C. So from our calculator, what is 10 cos 45? 4 decimal places. 7.0712 is equal to CE. So line CE measures 7.0712 kilometers. So that is the length of line CE. So can we calculate how far east the cyclist had traveled? from the starting point, yes. So how far east? So let me use this line. How far east the cyclist has traveled. So how far east? As we said, from A to F, but it has been divided into two. One part measuring 5 kilometers, and then the other part. So although we have calculated for line CE, we see that line CE is also the same as line GF. So if CE measures 7.0712 kilometers, then line GF will also measure 7.0712 kilometers. So what is 5 kilometers plus 7.0712? So 12.0712 kilometers. But we were told to correct our answer to the nearest kilometer in degrees. So to the nearest kilometer, or the nearest kilometer, that is 12 kilometers. So that is the A part, how far east you have traveled. So can we calculate how far north the cyclists have traveled from the starting point? We can do that. So B. So we also need to refer from the same right angle triangle. So from triangle CDE. This time we are looking for the length of the opposite, because we are looking for how far north. So let's calculate this height here. So to calculate this height, we have to consider our opposite and then our hypotenuse. So from SOHCAHTOA, which of them has opposite hypotenuse? So what does SO says? SO says that the sine of the acute angle 45 is equal to the length of the opposite. So there's the length of the opposite. So I'm naming it line ED divided by the length of the hypotenuse, which measures 10 kilometers. So sine 45 is the same as sine 45 on 1. So we can cross multiply 10 times sine 45. So that is 10 sine 45, and the 1 times ED. So from our calculator, 10 sine 45 is also giving us 7. So for the decimal place, 7.0712. So line ED measures 7.0712 kilometers. So can we calculate how far north the cyclists have traveled from the starting point? How far north? Yes. So how far north you have traveled? So how far north the cyclist has traveled? So for how far north you have traveled, said that would be from line F to line D. So this height here. But again, we see that it has been divided into two. It has been divided into two. One part measuring 10 kilometers. So 10 kilometers plus line ED. What do we get for line ED? So we had line ED to be 7.0712 kilometers. So let's sum up the two. 10 kilometers, so that should give us 17.0712 kilometers. But again, we have to correct our answer to the nearest kilometer. So to the nearest kilometer, that should give us 17 kilometers. So we are done with how far north we have traveled from the starting point. Now C. You have to find the distance and bearing of the cyclist destination from town A. So first of all, let's start with the distance. So the distance from town A. So distance from town A. So where did he start the journey from? From town A. And what is his destination? D. So the distance. How do you get a distance? You need to join the 2 points to get a distance. You need to join the 2 points to get a distance. So you are looking for the distance or the length of line AD. Line AD. That is his distance. The distance of his destination from the starting point. Line AD. So again, you will see that we are having a right angle triangle here. That is, let me draw this in red ink. The bigger right angle triangle. So this is a right angle triangle. So this angle here must measure 90 degrees, as you can see. So now how do we calculate this distance here? Now, do we know how far east he had traveled? Yes, we know that. We know how far east he had traveled. Do we know how far north he had traveled? Yes, we know how far north he had traveled. So from Pythagoras theorem, that should guide us solve the length of line AD. So from Pythagoras theorem, from Pythagoras theorem. So what does this theorem say? This theorem says that the square of the longest side, so that is the hypotenuse. So I'm naming it as line AD squared must be equal to the sum of the squares of the other two sides. So the first side, line AF, which is how far east you have traveled. We had 12 kilometers, but we are not going to use the estimated value. We're going to use the 4 decimal places. So 12.0712 squared plus how far north you traveled. We're not going to use the estimated value. We're going to use this 4 decimal places. 17.0712 all squared. So since we don't have much space, let's enter the whole of this value into the calculator's menu. So 12.0712 all squared plus 17.0712 all squared. So to 4 decimal place, 437.1397. Oh, square 437.1397. So now we are looking for AD, not AD square. So we can take the square root on both sides. So the square root and the square will cancel out, leaving AD is equal to square root of 437.1397. 20.9079. So to the nearest kilometer. To the nearest kilometer. To the nearest kilometer. So that should give us 21 kilometers. So that is to the nearest kilometer. Now, our final one, so I'm naming this as CI. So CII, we have to calculate, CII says that we have to find the bearing of the cyclist destination from town A. We have to find the bearing of the cyclist destination from where? From town A. So we know that in bearings, from, that is where we have to measure the bearing. So from town A, we have to measure its bearing from town A. We are looking for the bearing of its final destination. This is its final destination from town A. And we know that angles are read from the geographical north in the clockwise direction. So from the starting point to this point, this is what we are looking for. This is the bearing we are looking for. So from the geographical north until we get to the line that connects its final destination. So we are looking for this angle here. We are looking for this angle here. So how then do we get this angle? So now let's look at something. If I place theta here, we see that this theta here, this is a parallel line. This is also another parallel line. So this theta here is alternating with this angle here. So this theta here is alternating with an angle here. So if here measures theta, then this angle here must also measure theta. That angle there must also measure theta. So let's calculate the value of theta, and that becomes the bearing. So indirectly, this is the bearing we are looking for. But this bearing here, this angle here, alternates with this angle, which is inside the bigger right angle triangle. So let's calculate the theta using the bigger right angle triangle. So how did we name the bigger right angle triangle? So from triangle, how do we name it? So let's name it triangle ADF. So from triangle ADF. Now let's take note. This time, there is our acute angle. And we're making reference to the bigger right angle triangle. So this side here becomes our opposite. Let's take note. This side becomes our opposite. That is how far east your travel becomes the opposite. This side here is the hypotenuse, the longest side, because it's a side facing a 90 degrees angle. So this is our hypotenuse. So this side here becomes our adjacent. So to calculate this theta, we know how far east you have traveled. We also know how far north you have traveled. So it means that we are supposed to go by using the opposite and then the adjacent. And from SOHCAHTOA, it's only TOA which has opposite adjacent. So from the bigger right angle triangle, tan theta, which is this angle, should be equal to the length of the opposite. Here the length of the opposite becomes how far east the cyclist traveled. And in the question, we are not going to use the estimated value. We're going to use the 4 decimal places, which is 12.0712. That is the opposite divided by the length of the adjacent. So this side becomes the adjacent. That is how far north he traveled. Again, we're not going to use this estimated value. We're going to use 17.0712. So how then do we calculate for theta? we need to take the tan inverse on both sides. So when you take the tan inverse of tan theta, the tan and its inverse will cancel out, leaving theta is equal to the tan inverse of 12.0712 divided by 17.0712. We're almost done. The rest is calculator work. The tan inverse of 12.0712 divided by 17.0712. So theta is 35.26 degrees. Theta is 35.26 degrees. Don't forget that we are asked to correct our final answer to the nearest degree. So to the nearest degree, theta becomes 35 degrees. So that is the cyclist bearing. That is the cyclist bearing of his final destination from town A. So that is what we have done. I hope you enjoyed this episode. The question is lengthy, but it's not difficult. So just have some break, and then after the break, sit down, watch the video again, and then you'll get the understanding. Thanks for watching.